The last thing I want to talk about is what are the advantages and disadvantages of ion-selective electrodes. If we look at the good things about them, these may seem like the ideal tool, right? We can have highly selective measurements. The ion-selective electrodes are not incredibly expensive compared to many analytical techniques. An electrode itself costs a few $100s, something like that. It's actually more expensive for the piece of equipment to measure the potential accurately. But and you can make membranes that are selective for specific types of ions. These seem wonderful, but there are some disadvantages to them. These are not without their flaws. So let's look first at the advantages, though. What are the good things? There we go. So the one that I already mentioned is one of the big advantages. Ion-selective electrodes are much less expensive than many competing techniques for measuring ions in solution. Another big advantage is they can measure large dynamic range, which means they can go many orders of magnitude in terms of concentration. If you think about a pH electrode, it can measure pHs from 2 up to 12. That's like 10 different orders of magnitude in terms of hydrogen ion concentration. That's a huge dynamic range where you can use just one piece of equipment to measure anything from 10 to the minus 2 molar all the way to 10 to the minus 12 molar, which is pretty amazing. Another big advantage of this technique is that your sample isn't consumed. You don't need to, you can just put the electrode into the solution you're measuring, take your measurement, take the electrode out, you still have your sample that you started with. This also means that you can monitor things as they're happening. Let's say you're in a factory or something and you want to measure your solution but not have to take it out of the process. You can have your electrode go right into that solution as long as the solution is compatible with that. It ideally doesn't contaminate your sample, and the response time is pretty quick, typically less than a minute. It's not instantaneous. It does take some time for things to equilibrate, but it's not very long to get a measurement. So there's a lot of really great advantages of ion-selective electrodes and why they've become fairly commonly in use for analytical chemistry. But of course, there are the disadvantages. One big disadvantage is that the precision is low, often worse than 1%. So if you want to get a very accurate, you want to know your number really well, ion-selective electrodes are not great for that. If you want to know your pH to the exact, 0.01 or whatever, you saw this hopefully with measurements that you've already taken, but there's drift, these things move around, you have junction potentials you worry about, so precisions can be low. If you're looking at organic solutes, they can interfere and foul your electrodes depending on what they're constructed out of, particularly liquid-based electrodes, right? If you have something that is hydrophobic that you're in your solution that you're measuring, it can go into the electrode and mess with the carefully balanced equilibrium that you have there and mess up your electrode. One of the big disadvantages is that ion-selective electrodes are only so selective. There may be other ions that may interfere with the analyte you're trying to measure. And often it's things that are similar in terms of chemistry. So if you're using say a chloride electrode, other halide ions are going to be something that will show up. Some electrodes are fragile, so they may be less expensive, but if they break, there's not much use. And another big disadvantage of ion-selective electrodes are that they only measure the activity of free ions. This is something I didn't emphasize in previous videos, but all of those equations we wrote specifically depend on the activity of the free ions in solution, right? So if we're, say, talking about that potassium electrode, if the potassium complexes to anything else, it won't show up, right, in terms of the ion-selective electrode. It won't affect that membrane potential. So there are other techniques where you can measure the amount of all ions, no matter what form they're in, or all atoms or elements. And we'll get to atomic absorption spectroscopy, for example, is one that can do this. And so depending on your use case, your application, maybe all you need to know is the concentration of free ions. Maybe your ion you're measuring doesn't complex with other things. Then ion-selective electrodes are great. But if you need to know, all the amount of, say, iron or whatever, maybe ion-selective electrodes are not the way to go. So these are things to be thinking about. And when we talk about any specific technique, there's always going to be a list of things like this, advantages and disadvantages. And that's why we have many different competing techniques to measure, often the same thing. Is, the use case is different. Maybe we're willing to spend more money. And so, maybe, the advantage of an ion-selective electrode being cheap doesn't help you. Or maybe, you do need to save money. You want to do this very inexpensively, and ion-selective electrode makes a great choice then. So, we've talked about this already, but, these are some of the things you have to think about as you're thinking about making an actual measurement. So this concludes Chapter 15 on potentiometry, and we'll move forward in our next chapter to looking at spectrophotometry.